Hey guys, how's it going? So let's hop into this discriminant classwork here. I've already written down the equation for the discriminant. That is d is equal to b squared minus 4ac. It is the part of the quadratic formula that is under the square root, and it's going to help us determine what type of solutions we have and how many of those solutions we have. Remember, the possibilities are 0, 1, or 2. And let's go from there. So we're going to start off. We're going to go ahead and figure out what A is right away. It's -4, B is -3, C is +7. So that is the number that is in front of the x squared, the number that's in front of the x, the number that is by itself. And that's all we have to do. Plug it in right away. We got -3 squared minus 4 multiplied by AC. So A is also -4, and then C is 7. We're just replacing B there, replaced A there, replaced C there, replaced, and plugging it into the calculator in one step, and you will get 121. If you need help with your calculator, plugging that in, let me know. Because D is a positive number, we say that means there are two real solutions. If you want to be more fancy about it and say two real distinct solutions or two real roots or however you want to say it, all good with me. Let's go on to number 2. So number 2 isn't quite set up correctly yet because we don't have the equal to 0 over here. So we're going to have to start by subtracting 9 on both sides of the equation. So we're going to get -8x squared minus 8x minus 2 is equal to 0. And then after that, we can actually do the question. A is -8, B is -8, C is -2. And therefore, D is equal to -8 squared minus 4AC. And if you calculate this time, what are we going to get? We're going to get 64 and then 1, 2, 3 negative. So actually minus something, minus 32 times 2. Oh, it's 0. Holy moly. So if D is equal to 0, that means we have one real solution or one real root. I'm going to write root this time. The word solution and the word root all mean the same thing. So I'm going to use different answers in every one to just increase that vocabulary a little bit. So number 3, we're going to go ahead and add 5 to both sides for exactly the same reason. We get 2n squared minus 2n plus 5 is equal to 0. And then just gotta start putting it into the equation. A is equal to 2, B is equal to -2, C is equal to 5. So therefore D is equal to -2 squared minus 4AC. And if you plug all that into the calculator, we'll get 4 minus, what's that going to be, 2040, so -36. And because D is a negative number, we say we have two imaginary zeros. And again, we could have said solutions, we could have said roots, a lot of different words you could use. I'm using the solutions, roots, and zeros. They're all the same thing. And that's it. Continuing on, we're going to go ahead and subtract 2 from both sides here to start. -3 k squared minus 2k minus 10 is equal to 0 this time. So A is equal to -3, B is equal to -2, C is equal to -10. And we'll have D is equal to -2 squared minus 4AC. Looks like D is going to be 4, and then it's actually going to be a minus this time. So 120, so -116. And again, same exact answer as this. I'm going to be too lazy. I'm just going to say, hey, write it again. Two imaginary zeros. That's it. So that's all for the new lesson. The remaining parts of these questions are all going to be done with the quadratic formula or completing the square or however you really feel like. Because most students prefer the quadratic formula, I am going to use that on numbers 5 and 7. Let's hop to it. So question number 5. Whichever method you prefer, I'm going to use that quadratic formula. In case you don't remember what that is, that's going to be -b plus or minus the square root of b squared minus 4ac all divided by 2a. This question, a is 12, B is -2, and C is +5. Now, one problem you run into on this particular question is that if you were to plug it all into the calculator right away, it will give you I answers. It means that the calculator is going to throw you an error that you can't use the fraction bar because it doesn't have the correct data type. Or if your calculator's not even set up correctly, it'll tell you non-real solution, and that won't work. So this one you actually have to do a little bit more by hand. So let's check out how we could do some more of it by hand. We have negative of -2 plus or minus the square root of b squared minus 4ac. And just as a throwback for a moment, this right here, this guy on the inside here, that is your discriminant. And because the discriminant is negative, we have two I answers over 2a. And again, if you plug in the calculator, it won't work for you. So you do have to do it kind of piece by piece here. So we're going to go ahead and put a 2, negative of negative as a positive, divided by 24 plus or minus. We're going to make it two separate fractions to make our life easier. And plug in all that into the calculator, we get -236 if you do it correctly. So that means x is equal to 1 over 12. That's the reducing of 2 over 24. And square root of 236 with an I on the outside divided by 24. I would not be surprised if this reduces. We do not need to reduce it more in this class. If you would like help doing that, please let me know. I'll show you how to reduce that further. You can just leave it like that. If you're confused as to what happened from this step to this step, I'm going to re-explain that negative here on the inside of the square root. It means imaginary number. So we kind of take the I to the outside and we just rewrite it. That's all you have to do for these questions, is leave it like that. Question number 6. For this particular problem, this is technically an Algebra 1 question. I want to remind you as to how you could use your Algebra 1 skills to solve this. So we could start by simply adding 96 to both sides of the equation. And then divide both sides by 6. Oh boy, 10, 16. So what I meant by Algebra 1 question is now, if you notice, we can just take the square root of both sides. And if we just square root of both sides, we get our p is equal to plus or minus 4. And that is so much faster than doing all of our quadratic formulas and all this other stuff that we could be doing. So don't overwork yourself on questions that are actually nice and simple if you're willing to go back to those Algebra 1 techniques. All right, number 7. So this one, numbers look big. I think we can just go ahead and start by adding 8 to both sides. We got 6x squared plus 11x plus 4 is equal to 0. I'm going to think for a moment really quick. Does anything multiply to 24 and add to 11? 8 and 3 do. So this one's going to be factorable. So because it's factorable, I'm going to factor so I don't have to do all this. I don't like doing quadratic formula if I don't have to. So in this one, 6 times 4 is equal to 24. And we also know that 3 times 8 is 24, and 3 times 8 add to 11. So I can rewrite this. Dividing down the center, factoring out of 3x. Factoring out of 4, and 2x plus 1 is factored out. You get 3x plus 4 taken out is equal to 0, and therefore we have 2x plus 1 equals 0, 3x plus 4 equals 0, and subtract 1 divided by 2, negative a half, subtract 4 divided by 3, and there we go. So again, you could use quadratic formula if you wanted to. You'll get to the same spot, use your calculator for that. Or this factoring, that works. Or you could have completed the square. That would have had some crazy fractions. Don't recommend that. Yeah, I prefer factoring. Number 8, same idea, a squared. By the way, I put this question on exactly because it's on our benchmarks. This question, for some reason, this exact number shows up on benchmarks. You subtract 7 on both sides. That's all we have to do there. So we're just moving the 7 over. And then we take the square root. And we just have to remember, when we take the square root of a negative number, we rewrite it with the I on the outside. And that's the whole question. That's it. Let's finish it up. Let's turn it to the back side here. So we just have a few more to go. Same great first step here. We're going to add 9 to both sides. And this one, I'm going to go ahead and use the quadratic formula. This time, this one, I don't think we're going to do 7 times 12 and figure out what multiplies to, 84 and adds to -9. Not part of my game plan right now. A equals 12, B equals -9, C equals 7. And therefore, x is equal to negative b plus or minus our square root of b squared minus 4ac all divided by 2 times a. And on this one, yet again, if you do the calculator work for this, you'll end up with 81 minus a number that is larger than 81. So you'll end up with a negative number of some kind. I'm trying to figure that out right now because I am cheating. You get negative 255. So you get x is equal to 9 over 24, which does reduce, plus or minus the square root of negative 255 divided by 24. Rewriting our final answer. These both divide by 3, so I can. So 3 divided by 8 is equal to 255. X equals 3 over 8 plus or minus the square root of 255 divided by 24 with an I on the outside. And yet again, I'm pretty sure that that guy reduces, but if you would like to do that with me, just let me know. For numbers 10 and 11, it says graph using whichever method you prefer. I don't really care how you do it this time. The quiz for that is over. Most people are going to choose to use the calculator. For this particular question, I'm just going to go ahead and actually do the whole completing the square thing to make sure that my vertex is perfect. But you don't absolutely have to do this if you've mastered your calculator skills. So we have the -1, 2, divide by 2 square. Boom, boom, boom. That's what we're adding to both sides. You get x squared plus 2x plus 1 minus 1 because we added 1 here. You got to subtract 1 there. And we're going to get f of x is equal to x plus 1 squared minus 2, which means that we have a vertex at -1, comma -2. And there's restart. And then if anyone wants to come in after school and talk to me about it, I can show you a cute little trick about how you can instantly find these other values without a calculator. There is a way to do it. I would like to kind of show you the logic behind it. But for now, if you're fine using your calculator, that's fine too. Continuing on for our very last question. This one, good time to practice actually completing that square so you can get that perfect vertex. -2 x squared plus 4x minus 6. If you're wondering what happened there, just to think about it for a second, that -6 got copied on the outside. The -2 is dividing into the -8 to give us +4. That +4 is coming up to the outside here. We got 4, divide by 2, put a star and square it. So we're adding 4 here. But if you add 4 there, you also must subtract on the outside, but it not actually is adding 4. It's actually subtracting 8. So we have to add 8 over here. And we get f of x is equal to -2 x plus 2 squared plus 2, which means that we have -2 comma +2 as our kind of starting value way up there. And just as a reminder as to how to get the extra values, you can plug in the numbers. You can, there's a lot of different things you could do. Plug in the numbers. You can use your calculator. I personally do not care which method you use, but I do want to show you some other cute little tricks. If you plug in 0 right away, there's -6 right there. So you can get this one using that axis of symmetry, the mirror image idea. There must be another one exactly right here. And we can again use that mirror image idea, and we'll get these 2 coordinates as our other ones. Don't forget to try to make it as curvy as possible. And that's it. Have a wonderful rest of your day or night or whatever time it is for you, and have a good one.